Okay, if you're going to do that, then I'm going to send you out and you'll fend for yourself. And whatever's in the hallway, yes. Okay, CBA review. This is what we're talking about from the first 9 weeks. Everything on this paper has been taught. Those numbers going across the top are not very legible on your paper, hence why I wrote them on the board. But I also want you to cross out the word counting, because counting means natural. And we're going to classify natural, whole, integer, irrational, or rational. But I want you to do this in a list on separate paper, which is in your notebook, because I asked you to take it out. So real quick, on the next blank spot of notebook paper, let's jot down what these numbers mean. Rational. Irrational. Actually, let's go in order. Integer, whole, natural, and irrational. And we got to come up with some brief descriptions. So, what's a rational number? Who can explain that in quick terms?
So rational number, it's just like a number that can kind of like withhold any other number. That's whole, integer, natural.
Okay, so it encompasses these groups below it. All right, how do I define it? Who has their notes out and open? Yes. Fractions and certain types of decimals. They're positive or negative. Decimals that are what? That terminate, good. Or what? Or what? Repeat, good. An integer is what? Whole numbers and their opposites. What do you mean by opposite? Good. Are there any decimals or fractions? No, unless they equal 0 or unless they simplify to a whole number or its opposite. What's a whole number? Counting number and what? And 0. Good. What's a natural number? Counting numbers. What's irrational? Okay, infinite what? Decimal that what? Doesn't repeat. Good. Teamwork makes the dream work. Infinite, non-repeating, decimal, like pi, because that's what you said, right? Also, is who else? Good, the imperfect squares. That would be an example. So like the square root of 170 or the negative square root of 170. 18 pi. Okay, those are all irrational numbers. So now looking at the numbers that I have listed or in a chart on number 1, I need to list them and talk about where I would put them in this diagram. Do you remember this one? What goes over here? Irrational. And then I've got some concentric groups over here. What goes inside? Natural. Counting. What goes next? After that? And after that? Now remember, like it was mentioned earlier, rational encompasses these group below it. So natural is also whole, also integer, and also rational. An integer is also rational, and a whole is also rational. But when I'm listing these numbers on number 1, I want to talk about where I would place it in this chart. So the first one up here on the board and also on my paper is 5 pi. So where would I place 5 pi? Irrational. The next one is the opposite of square root of 64. Put that in a calculator. Don't just guess, because I don't feel like you've memorized your perfect squares. Good, -8. So what type of number will I put, or where will I put -8? Integer. All right, 30 over 3. It's 10. So where does that go? Natural. 18/9. Why? Because it simplifies to 2. 780. Natural again. Good. Negative square root of 18. Calculate it. Irrational. Why? Because it's not a perfect square. 13. What is it? Natural. 14. I'm sorry, -14. Integer. 70 over 7. Natural, because it equals what? 10. 72 over 2. Natural, good. What will it equal? 36. Speaking of 36, square root of 36. 6 is natural. Good, y'all. Negative square root of 9. -3, so it's an integer. 4 pi. Anything with a pi is irrational. 300. Square root of 209. Good. The opposite of 39. Good. 1.9. Why is it rational? Because it terminates. What does terminate mean? It stops. It ends. Where'd I leave off? -2/3. Which one? I heard ear. Is it irrational or not?
It's rational.
Rational. Why?
It's because it's a decimal.
A decimal that what?
That ends.
It doesn't end. It repeats. What is -2/3 as a decimal?
Oh, yeah, it's 69.
-0.66 repeats. Next one.
What would be?
If it repeats, it is infinite, but it's not infinite. Non-repeating is irrational. -8.2. Say that again. Rational. 2 pi.
Irrational.
6 and 84/100 repeats.
Rational.
Which one?
Rational.
Rational,
Because it repeats.
because it repeats. Good. 12 and a half. Yep. 0.67 repeats. What did we just say about repeating? Rational. The opposite of square root of 121. Integer. Good. What's the square root of 121? What's the opposite of that? Good. Square root 20. Irrational. Good. And then 15 fifths.
That's 3.
Good. So what number, what kind of number? Natural is where I would start classifying this. Okay. All right. Going on to question number 2, where it says standard notation and scientific notation. Remember, if your exponent is negative, the standard number is less than whom? Good. Standard number is less than 1. If your exponent is positive, then the standard number is good. I'm not going to do the exact ones on your homework, but I'm going to write like letter A. If I have 0.00000685, then scientifically it would be what? Like letter B. If I'm at 6 times 10 to the 4, then I would convert it to what? And like letter C. And like letter D. This is negative, by the way. This is a negative 5. Okay. Excuse me. So, doing my examples, how would I write this in scientific notation? What is my number that goes first? 6.85. Because it's between who and what? 1 and 10. Then what's the rest? Times 10. Let's count. 1, 2, 3, 4, 5. To the negative 5. Count the zeros and the one place that you put between 1 and 10. This one, 6 times 10 to the 4. Yes. 60,000. 6 with what? 4 zeros, not 4 tens. 4 zeros. Now, how would I write this one? 4.2 and everything after it. Times 10 to the what?
I thought scientific notation was to make 7. To make writing it shorter. 5, 6, 7.
It's 7. And the last one? How many zeros after the decimal? No, it's not 9. 8, because you have to leave a space for the 3. All right, those are the examples for that. Our video is about to